Hey everybody, Paul here. For this week, we are going to be talking about probability for this first video, not really calculating as many probabilities, really trying to think about what probability means, right? Will an outcome occur is the title of this. So up here we have a number line, and it's a very simple number line. It starts with 0 on the left, and it goes to 1 on the right. And this number line represents all of the possible probability values of everything that could ever happen. So on the far left side, we have a probability of 0. Probability equals 0 means the thing is impossible to happen, right? And on the far right side, we have probability of 1, and that means the thing is certain to happen. And then in the middle, somewhere around here, right, we have a probability of, I think that would be like 0.5 or whatever, and that means that the thing is equally likely to happen or not happen. So let's just put some names to those things, right? So notice we have impossible, unlikely, less likely, equal chance, right? That's that 50% thing. More likely, very likely, and then certain. And as you said here in the middle, right, we would have our 1/2 or our 0.5 for the probability, right? Now, we don't always use percentages, but we could also use percentages for this as well, right? Notice over here we have 0%, and over here we have 100%. Those are those same things of impossible and certain. And in the middle here, there's that 50%, okay? So couple things, we're going to look at some really straightforward questions and then talk a little bit about what the probabilities mean, right? So our first one, you flip a coin. What's the probability you get a heads? So we've seen this example a number of times. We know the probability that you get a heads when you flip a coin is 1/2, right? So that's right in that middle there. That's that equal chance 50%, okay? What would be the probability that you get a tails? Well, in this case, probably that you get a tails is also 1/2, right? And notice that for flipping a coin, there's only two things. There's a heads or a tails. Another way to think of that is that there's a probability of getting a heads or getting a not heads, and they're both 50%. That is what we mean when we use the phrase 50-50. What is that? Zeroed up there. There's a 0 for it. 50-50. That's what 50-50 means. It doesn't just mean that it's an equal chance, and it doesn't just mean that something's 50% to happen. It means that it's 50% to happen and 50% to not happen, right? So flipping a coin, it's heads or not heads at 50%, right? Here's another one, right? You roll a die. What's the probability that you get a 1? Well, we know that a die has 6 sides, and one of those 6 sides has the number 1 on it. So the probability of getting a 1 should be 1 out of 6. Now, where is 1 out of 6 on this number line? Well, it's down here. It's in this less likely or unlikely area. It's right about there, I would say, right? That's about 1 out of 6. Okay? So the probability that you roll a 1 on a die is not super likely, right? Kind of unlikely. What about that you roll a 2? Well, I mean, a 2, there's exactly 1 2 on a die also, right? Right there, that guy. And so the probability that you would roll a 2 should also be 1 out of 6, right? Don't get thrown off by the fact that this number is a 2. It's just one of the 6 outcomes, so it would be 1 out of 6. And notice that's in the exact same spot as rolling a 1. So you have equally likely outcomes for 1 and 2. Would we describe those as being a 50-50 chance, right? Like heads and tails is 50-50. They were equally likely. And 1 and 2 are 1/6 and 1/6. They're equally likely to happen, right? What's going on here? Well, I think the key thing is when we talk about something being an equal chance, it doesn't mean that two outcomes are an equal chance. It means it's an equal chance of the outcome happening and of the outcome not happening. So if we were to think about the probability of not 1, what would that be? What's the probability of not 1? Well, how many not 1s are there on this die? There's a 2 and a 3. Those are both not 1s. 4 is not a 1. 5 is not a 1. And 6 is not a 1. There's 5. And that would give us a 5/6 chance of that to not occur, right? To get a not 1, which is way over here in the very likely zone. So this is the reason why we wouldn't describe getting a 1 or a 2 as a 50-50 chance, because what we're really talking about, right, is a 1 or a not 1 if something should be 50-50. Okay, that's something we really wanted to stress, is like it's really easy to get caught up in probability using language and things you've done in the past and to misapply them. Okay? Let's look at a couple other examples. Got a new number line down here. Okay? Couple of questions, right? So the first one, the probability of rain is 80%. What is the probability of not rain? We've seen questions like this before. We learned that theoretically, if you add up the probability of something happening and the probability of it not happening, you should get 1, or you should get 100%. Right? Now, 80% over here, right? It's right about there, maybe a little bit to the side of that. So that's our 80%. There's our probability of rain. Our probability of not rain, right, should theoretically, like, if we think about this space right here, this distance, it would be the same distance on the other side to where not rain should occur, right? So that's like our 20%, which is our probability of not rain, okay? So which one's more likely, rain or not rain? Well, once you're past this 50% chance, it's more likely that the thing would happen. And if you're on this side of it, it's less likely that it would happen. So in this case, we would say that the probability of rain is 20%. If we wanted to give these decimals, they could be 0.8 and 0.2. And we know that the probability of rain is more likely because it's above 50%. Right? That's kind of what it means to be above 50%. It means it's more likely that it would occur. Now, a couple like weird cases, right? You flip a coin. What is the probability that you get a 6? So flipping a coin seems normal and getting a 6 seems normal, but together they seem kind of weird because we happen to know that a coin has two sides. Neither one of them is a 6. So we would say the probability of getting a 6 when you flip a coin is 0. And this is what a probability of 0 means. It means the thing is impossible. It means it can never happen, right? It's similar to probability of, like, if you say something is a probability of like 0.000001, yeah, that's a lot like 0, but it's not 0, right? It could happen. Often playing the lottery is something, a probability like this, right? But people win. You don't win. I don't win because it's very unlikely, but people win because it is possible, right? Now, on the flip side of this coin problem, we have a question about, okay, you are a senior at New Design High School. What is the probability that you are a student? I know this is a weird sounding question, but think about it. You know that someone's a senior. What's the probability that that person is a student? Well, in this case, right, because by definition, if you're a senior, you're a student, we would say the probability that you're a student is 1. This is what it means to have a probability that equals 1. Or if you want to think about it as a percent, 100%, right? It means it is certain to be true or certain to happen, right? If you flip a coin, what's the probability you get a heads or tails? It's 1, because that's the two options. You get a heads, you get a tails, right? So in a lot of the questions you're going to be answering, we're going to be asking you questions about the language of probability and about whether things are more or less likely. And this is really what we mean, right? Think about the number line. Think about if you need to convert any fractions to decimals to help you out, that's fine too. Hope everyone's doing well. We miss you all so much, and we look forward to seeing you guys soon. Okay.